This is the 2004 deferred paper, paper 1, question 5. So it's on calculus. So let's read this carefully and figure out what's being asked. There's a function fx, and it tells you here that the derivative of f dash of x is 6x plus 4. So straight away, this is probably different to the standard question because they're actually giving you the dy dx. If you read it carefully, the derivative is given to you. F dash x is 6x plus 4. So it looks like we're working backwards here already, which means trying to get fx. And you're supposed to know, I suppose, at honours level that working backwards is basically integration. So over here, I've just done a summary. If you have a function fx, you differentiate it to get f dash of x. But vice versa, if you have f dash of x, you have to integrate to go backwards to fx again, because differentiation and integration are inverse functions. So that's the first thing to spot in this question. It might throw somebody easily if you didn't read it carefully. So we're trying to work backwards here. Okay, so basically I've summarized it here. F dash of x is given to us, 6x plus 4. We've got to go backwards to get fx. So that means integrating. And we'll use this piece of information later that the point is on the graph. But first of all, let's just go backwards. So the integral of 6x plus 4, the rule is for powers, you can leave the 6 as it is. That doesn't affect things. Just worry about the x. So that's x to the power of 1. So increase the power, x squared divided by the new power, which is 2. 4 becomes 4x, because think backwards. If you differentiate 4x, you get 4. So integrate 4, you get 4x. And there's always a constant of integration at the end. Don't forget to put that in there, very important. So now, because we've integrated, we've basically done this step here. We've gone from f dash of x back. So now we have, it's important to realize what you have. You have fx at this stage. So this is fx. Now, the next problem is to get rid of the plus c. And for that, we can use the next piece of information, which is we're given a point on the graph, minus 1, 8. And here's a tip for all the exams, really. Whenever you get a point in F1, in paper 1 and paper 2, I find without exception, by labeling the point either xy or x1, y1 or whatever, that gives you the next step. So the next step is fill in x and y into your function, minus 1 and 8. So you come down here, fx is your y value, so that's 8, and fill in minus 1 for the x value. And you work it out, you square out the bracket, be careful with your bracket there, just square the x, and that's a minus 4, so you end up with 8 equals minus 1 plus c, c is 9. And after going to all the trouble, reward yourself, don't forget to put it back in, the c value that you got, put it back into fx, and now you have your function. So c is 9, so back in here, and now you have 3x squared plus 4x plus 9. And that's fx. That's what we were asked in the first part, to find fx. So just watch out for that if it ever turns up. It's the reverse of differentiation, which is integration. But they don't say the word integration, so you got to be alert for that clue that you're going backwards. Okay, the next part of the question. So still question 5, part B. You're given a function here, y equals x ln x cubed. Now, find the value of y when x is 2. So this is just a straightforward substitution. Put in the value of 2 for x. And you sub in 2 for x, and you get 2 cubed is 8. And then it's just calculator work. Make sure you get your 4 decimal places. This bit is important on your calculator. So that bit wasn't so bad. Part 2. I suppose something about exam technique as well is important here. Part A was that bit harder because we were working backwards, as I said. Part B was much easier, so it's a lesson in exams as well. If a part A is very hard or whatever, don't give up. Try the next part. It could be easier. So that's a good lesson in itself, and it was easier here. The next bit isn't so bad either if you know your differentiation, because we're asked to find the dy dx of that function right there. Now, so the function is x ln x cubed. You have to spot here that it's u by v. It's product rule. you'd be expected to spot that at honours level, that it's something multiplied by something, therefore it's always product rule. And there's no other way to do this. So, you have to spot this on the day. If it's something multiplied by something, it's product rule. If it's something divided by something, it's quotient rule. And the rule is in the tables, there it is. So be alert for this, have the tables page open, take down your formula. Now you write down u over here, you get du dx. You write down v over here, you get dv dx. Now v is tricky because there's an x cubed here. So what you have to do is look at the ln part first. And what's going on is ln, and in your tables ln always goes to 1 over. So the way to say it is the ln of a thing becomes 1 over the thing, whatever the thing is, and the thing is x cubed here. ln of a thing always goes to 1 over the thing, and that's in the tables. But within the thing, I call this, it's like a play, there's a plot and a subplot. The main plot is the ln, so we've dealt with that, 1 over x cubed. But there's a subplot within the plot, and the x cubed here is a kind of like a subplot. That has to be dealt with separately, differentiate separately. 3x squared. X cubed goes to 3x squared. And to bring the two of them together, it's the chain rule. You multiply your answers, basically. So the main plot, 1 over the thing. The subplot, take this separately and multiply your answers. So that's worth spending time at to get it right. Most people go wrong here. They forget about the 3x squared. So there it is. So you work it out. It's 3x squared over x cubed, which is 3 over x. Okay, so put it all back together. So this is what I call a divide and conquer rule. We take the complex problem here of x ln x cubed. We divide into two pieces, u and v, and we solve them separately. So that's the divide step. Now the conquer step, divide and conquer, bring it back together with this formula here, which is called the product rule. So just fill in the answers now, u dv dx. So it's u by dv dx plus v, which is here du dx. That by 1. And you end up with x, the x's cancel, you get 3 ln of x cubed. And that's the answer really, except he wants it written a particular way. Up here he wants it written as something plus something times ln x. So we don't quite have that yet. We have the something here, it's a 3. We don't have something times ln x. But again, if you know your rules in the tables, your rules of logs, you know that 3 comes down in front. So that 3 goes down in front here. So ln of a to the power of b is b ln a. So the 3 goes down in front, and there you have the answer in the format required, which is 3 plus 3 ln x. And that's question 5 completed. We'll go on to question 6 in the next video.